the AMC point, we are very interested in improving our patient logistics and in patient safety. And that's why we're interested in applying new technologies to see how we can improve, besides organizational issues and cultural issues, how we can improve with IT technology our patient safety and patient logistics.
Now, what kind of new IT technology would truly help establish this improvement? One of the solutions could be RFID technology. The acronym RFID means Radio Frequency Identification. An RFID tag is a small chip with an antenna. So small it would fit, for example, on an adhesive or a wristband. An RFID tag can be monitored with a transceiver. Every movement of the RFID tag passing the transceiver will be recorded. Thus, complex logistic processes of any kind can be closely monitored. To find out more about the possible improvements that RFID might bring to healthcare, the Academic Medical Center in Amsterdam carried out a pilot.
This pilot supports us in, I think, two ways. It first gives us insight in how processes are going, and second is that we can use quantitative data to improve our processes.
The main objective of this pilot was looking at the possibility of even further improvement and safety of the transfusion chain using the RFID techniques. One of the most important things was being able to check if the right patient is getting the right product. And beside that, we also looked at the storage condition of the product if it is in the clinical ward, concerning the temperature, the place, and we also were able to look at the right moment when the product was really transfused to the patient.
The RFID tags provide quality information on the whereabouts of patients, employees, blood products and disposables. People's movements can be monitored, not just to locate personnel, but also to check on waiting times for a patient or to find out if a person is actually the right patient for the planned surgery. Also, one can keep a close eye on logistics of blood and blood-related products. The tags are not only used to check the movements of the actual bags, but are also part of the quality control cycle. They're able to store information on location and temperature of the blood product.
The data we get from the pilot are the number of patients who go through a specific process, the waiting times, throughput times, data also on employees involved in these processes, also data about the use of disposables and the use of blood products.
Because of European guidelines, we need to be able to trace a blood product at any time after it had left our transfusion labs. And this RFID techniques enables us to do so.
The results of the pilot learned us many things. First of all, patients accept this technology very easily. Secondly, we learned a lot about our processes. And finally, we also can say that this technology can be safely applied in a high technological environment.
When surgery is finished, the tags on the disposables enable us to see exactly and on the level of a single patient which materials have been used and will be discarded. Management information is available about the overall use of materials during surgery. Furthermore, there's data available about the several steps in the process from the patient's point of view. Also, there's a clear set of records concerning the movements and quality of blood products. RFID tags supply a wealth of possibilities and create an environment for new applications to support professionals, processes, and most of all, the patient.
The business case behind the pilot will, on one side, learn us about the investment needed, and on the other side, it will give us an impression and potential about improvements in efficiency and in patient quality.
I think this technique has big potentials, especially also in the transfusion world.
Although more research is needed, we see great potential and we will continue working with RFID technology.
This RFID pilot has been sponsored by Intel, Giodan, Oracle, the Academic Medical Center Amsterdam and Capgemini.
you.